Hello children. So today let's get started with exercises of motion chapter. Okay, we'll be dealing with some numerical problems. So today we are gonna start with numerical problems of chapter motion. So the first question is, an athlete completes one round of a circular track of diameter 200 meter. You can see here 200 meter in 40 seconds. What will be the distance covered and displacement at the end of 2 minutes 20 seconds? Okay children, so let us see now, taking it as circular track. Okay, because the athlete is taking a round. Okay, so circular track where r is equals to radius, that is 100 meter, and t is equals to 40 seconds. So distance is equals to that we need to find out, and displacement also we need to find out. So this is the given data. Let us solve. So converting time, that is t is equals to 2 minutes 20 seconds. Okay, 2 minutes 20 seconds. So let us convert it to, that will become 140 seconds. Okay, so let us take a circular path. This is a circular path where let us divide it with 4 equal parts. Okay, we are dividing the circle in 4 equal parts. So let us take this as starting point. Starting. Okay, this is the circular path we have divided into 4 equal parts. So which is perpendicular at the middle. So it will be, this is all perpendicular at 90 degrees. Okay, so now taking as t is equals to 0. Okay, which is at starting point. Starting point. So then t is equals to 40 seconds. That is, it takes one round. The athlete takes one round to complete 40 seconds. So one round complete. That is at 40 seconds. T is equals to 80 seconds. So the second round is complete. Similarly, taking the third one. So 40, 80, 120. That is, third round is complete. Okay, we need to get 140, isn't it? We need to get 140. So let us take t is equals to 140 seconds, means the half of it. Okay, half in the sense it will be 3.5 round to get complete. Half we are taking, so t is equals to 140 seconds. Here you can see 1 complete round, 2 complete round, 3 complete round, and 3.5 will be here, the final point. Okay children, so let us draw the line. So it takes 3.5. Diametric is opposite. So distance covered in one round is equals to 2 pi r. We know that is 2 into 22 by 7 into 100. Okay children, distance covered in one round. So similarly, we'll calculate distance covered in 3.5 rounds. It will become 3.5 into 2 into 22 by 7 into 100. So by calculating all this, we will get the answer 2200 meter. So this is the distance covered in 3.5 rounds. Okay. So distance we got to know that 2200 meters. Okay. Now we need to find out the displacement. So the displacement is shortest displacement is shortest distance between final and initial position. So this is the initial position because it is at starting, and the final is here, final point. Shortest distance between final and initial point, that is displacement. We are gonna see. So it will be in this direction. From here it is coming to the final. So taking arrow mark this side. So displacement will be on the opposite side. Okay. 2 times the radius. So it will be 2 times the radius. So displacement after 140 seconds is equals to 2r. That is equals to 200 meters. Now you got an idea. So this is how we calculate displacement. Okay children. So it is 200 meter and we are at the final step of our answer. Now moving on to next question. So the second question is, Joseph jogs from one end A to the other end B of a straight 300 meter road in 2 minutes. Okay, 2 minutes 30 seconds he is taking. Then he turns around and jogs 100 meter back to point C. So he is going in one straight line and again he is coming back in return, where he takes another 1 minute. What are the Joseph's average speed and velocity in jogging A from A to B, and secondly the from A to C? So let us see. It will be like this is a straight line considering to be. Okay, let's point it as A and here as B. So he is jogging for 300 meters. Okay, Joseph wants to move from end A to end B in 2 minutes 30 seconds. Okay, and he turns again and jogs for 100 meters back. So 300 means 100 meters back. We'll consider, let's point it as C. Here he is jogging for 100 meters. Okay, and back. So let us take now as time AB and time BC. So the time is 150 seconds. Here it is 60 seconds. So how will, let us see. So it is average speed is equals to total distance divided by total time. Okay, So similarly, average velocity also. Average velocity is equals to total displacement divided by total time. Clear, children? So now let us see the speed. So the speed is equals to speed of AB is equals to 300 divided by 150. That will be 2 meter per second. Similarly, we can calculate velocity also. So similarly, we are calculating velocity, which is equal as same. That is, velocity of AB is 300 divided by 150. That we gives us 2 meter per second. Direction of A to B. So this is direction of A to B. Okay. So now we need to find out speed of AC. Isn't it? So how we'll find out? That is 300 plus 100. Okay. Divided by 150 plus 60. So here you can see 300 plus, again we are calculating here, that is 100, and 150 by 150 plus 60, that we get the answer 1.90 meter per second. This is the speed of AC. So how it will be? A plus B plus B plus C divided by A plus B plus B plus C. Similarly, calculating the velocity. Similarly, calculating velocity of AC. That is equals to, we need to find out. So how it will be? 200 divided by 150 plus 60. Okay. So what we get? The answer is 0.95 meter per second. So this is direction of A to C. Clear, children? This is how we have found out the answer from A to B and A to C. This is A to B, and here A to C and A to C. Now let us move on for the third question. Okay. The third question is, Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. Okay. On his return trip along the same route, there is less traffic and the average speed is 30 km per hour. What is the average speed for Abdul's trip? So we need to take Abdul while driving to school computes average speed for his trip to 20 km per hour. So now let us take it as, this is a point, and here also a point to be taken. Let us take A from house location. Okay, this is the house location, and B as school location. Okay. So taking the distance as x, let us take the distance as x. So this is the total path length. This is the total path length. Now let us find out. Let us see how it comes out. So speed of AB. Okay. Speed of AB is equals to 20 km per hour. On his return trip along same school to home, it is speed of B to A. That is, this is return trip. Okay. Return trip. That is 30 kilometer per hour. So what is the average speed of Abdul's trip? We are gonna find out. So how the average speed can be calculated? So it is initial position and final position. Speed of A we need to find out. Initial to final. Let us take average speed. Okay. As we know, to find out average speed is calculated by total distance divided by total time. Isn't it? This is how we are going to find out average speed. So let us see. That is A to B is X. So A to B it is X. And again B to A is also X. So X, taking X plus X is equals to 2X. Okay. So we need to take time. So we are about to calculate the time now. So it will be time A to B and time B to A. So time B to A is equals to distance by, so time A to B, it is equals to distance divided by speed. That is equals to X divided by V1. Okay. Similarly, time B to A, we'll see X by V2. This is velocity 1 and this is velocity 2. Okay. Now got, I hope, this is velocity 1 and this is velocity 2. Now we'll find out the speed of initial to final, or else final to initial. So that is X plus X divided by X divided by V1 plus X divided by V2. This is the formula to be calculated like this. So X plus X becomes 2X divided by X taking as common into 1 by V1 plus 1 by V2. Isn't it, children? Can take it like easily. Okay, 2X. X plus X becomes 2X, whereas taking X common, 1 by V1 plus 1 by V2. So from LCM formula, speed of A to A, that is 2 divided by, can we take it like this, taking 2 common, V2 plus V1 divided by V1 plus V2. So this will overcome upside. Okay, this will come up. Okay, what is the thing that we get? That is speed of A, that is equals to 2 will remain like this, whereas taking upside it will become 2 V1 V2 divided by, it will be remain same thing. So V1 plus V2. So putting now the values, this is the picture and now we are going to put the values. So the values is, so now adding values. So by adding values we will get 2 into, as we have gotten 20 km per hour and 30 km per hour. Okay. So 2 into 20. So again 30 divided by 20 plus 30. So the answer that we get is 24 km per hour. Hence the required answer is what we have got. Required answer is 20 km per hour. This is how simple to be calculated. This is the formula to be taken like this. Okay. Now let us move on to the fourth question. The fourth question is so easy with the simple formulas. The fourth one is, a motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3.0 meter per second square for 8 seconds. Okay. How far does the boat travel during this time? So a motorboat starting from rest, that is equals to u is equals to 0, accelerates in a straight line at constant, okay, at rate of 3.0. So it accelerates 3 meter per second. So it is constant because it is moving in straight line. So it is constant. Okay. For how long? We'll see. Time is 8 seconds because it is moving in straight line for 3 meter per second square and for 8 seconds. So time is 8 seconds. We need to find out displacement. So we need to find displacement. So let us see the equations of motion now. Equations of motion. So equations of motions, we have 3 equations, isn't it? That is v is equals to u plus at, and one other is x is equals to ut plus half at square, and thirdly we have v square minus u square is equals to 2as. So here we need to find out the answer. So s is not here, displacement s is not here, so this cannot be taken. Displacement is not here, so we are not gonna take. And here t is not there, isn't it? V square u square is equals to 2ac, so t is not here, so even this is not possible. Here s is also there and t is also there, so this can be gives the answer. This may give us answer. So let us check it. S is equals to ut plus half at square. Taking the formula. So what is this? Displacement we are going to find out. So u is 0, t is 8 seconds plus half into acceleration is 3 and again the time is 8 square. So which we get the answer by all calculating this is we get 96 meters. So this is the displacement. Okay children, this is how we need to calculate this. Now let us move on to the one other question. So the fifth question. A driver of car traveling at 52 km per hour applies the brake and accelerates uniformly in the opposite direction. Okay, the car stops in 5 seconds. Another driver going at 3 km per hour in another car applies his brake slowly and stops in 10 seconds. On the same graph paper, plot the speed of versus time graph for the two cars. Which of the two cars traveled further after the brakes were applied? This is the question that we are going to find out the answer for this. So let us take with the given data. So initially it is 52 km. So here there are two cars, car 1 and car 2. So initial it is 52 km per hour from given data. Acceleration is equals to constant because it is in uniform. Okay, acceleration is uniform, so we are taking it as constant. So velocity is 0 and time is equals to 5 seconds. The car 1, 5 seconds. Okay, let us take another car, car 2. So let us not mix it. So we'll write it in capital way. So initially it will be 3 km per hour. Okay. So acceleration is constant comparing with before. So it is constant. We are comparing here, children. You have to go through with this. We are comparing. So it is again constant. And velocity is 0. So time is 10 seconds here. And here it is 5 seconds. So let us plot a speed time graph. So let us plot speed. Let us plot speed time graph. Okay. So it is in straight line. Straight line where A is equals to constant. Okay. Compare distance traveled by 2 cars. We are comparing here. So it comparing distance traveled by 2 cars. Okay, let us now compare. Plotting a graph. So let us take x-axis as time, x-axis, and y-axis as speed. So we are plotting a graph. Let us take 2 points, that is 5 and 10. Time 5 seconds and 10 seconds here. So again we need to plot the speed. So let us plot with initial, that is 3 seconds. Okay. So let us take it like 3, 6, 9. So by taking, we need to go up to 52 km per hour. So let us plot a point here for 52 km per hour. Here it is 3 km per hour, 6, 9. Okay. Time t is equals to initial, where 0, 52. Let us take t is equals to 0, that is for initial. For this is for initial, where t 0 is equals to time 0 will be initial point, that is 52 km per hour. So let us mark a point over here. Okay, we have marked it. Similarly, we need to calculate for time 5 also, seconds, that is t5 is equals to speed is equals to 0. So again we are gonna mark one other point here. Okay, we have got 2 points. So let us draw a line, straight line. Okay children, so this is for car 1 for 52 km per hour, and again time for t is equals to speed is equals to 0, and again here we have got 2 points and we have drawn a line through over. And now moving on to the, this is for car graph of 1. This is the car graph of 1. And similarly we need to take one other graph. With the same graph we need to calculate car 2, the graph. So here t is equals to 0, where it will be initial velocity is equals to 3 km per hour. So taking mark over here 1.3 km per hour, and similarly for time t, that is equals to 10. So it will be taking one other point here. So we have got 2 points. Let us draw a straight line. So this is the speed time graph for 2 cars. Okay. Now calculating the velocities. So we need to calculate velocity. So area enclosed by speed time graph, and time axis is equal to magnitude of the distance traveled. So we are calculating the area. So this is one area and this is one other area. Let us find out the distance. So distance of car 1. Okay. Let us take half into 5, and because 5 here is time, and 52 into 5 by 18. Okay. 52 is for car 1. Initial velocity, that is 52. And here 5 by 18, how we have got? So SI unit of meter per second, how we'll calculate? Let us take a small note here. So 52 by 1 is equals to, how we are going to find out the SI meter of SI unit. So 52 into 1000 divided by 36,000, taking time. Okay, so that is 36,000. By calculating this goes 5 times and this becomes 18. So we have got the answer 5 by 18. So taking here as 5 by 18. Okay, by calculating this, half into 5 into 52 into 5 by 18, the answer what we get is 36.11 meter. This is the distance of car 1. Similarly, let us take the distance for car 2. Distance of car 2. Okay. Same with the same formula. That is, but the car is different here. Half into 10 into 3. Initial velocity is 3 into again here 5 by 18. It is constant. Okay, by calculating this, we will get the answer 4.16 meter. This is the distance of car 1 and car 2. I hope children now you got an idea how to solve the problems. Thank you.